Good morning, ladies and gentlemen. Welcome to our webinar today on total Listeria management. I say good morning. Of course, we have registrants from all over the UK, from Europe, and as far afield as New Zealand. So, good morning, good afternoon, good evening, good night, whatever time it is for you. Hello. Please do you can join us. So, for the next couple of hours, with a break in the middle, we'll be talking through on total Listeria management. Marvelous. So our list of speakers today, I'll leave to give a brief introduction to themselves as we go through, but you can see we've got some superb speakers and with some real expertise in the area of Listeria management. Our agenda for today. Sorry, I've got the webinar pinging at me saying I've got people waiting in the lobby, but they're coming in automatically. Apologies for that. Why can't people leave Teams alone? Stop changing it. So you can see our agenda for today. We'll open with Karen Goodburn from the Chilled Food Association, who'll be talking us through Listeria, current issues and legislative controls. We'll then move on to our total Listeria management package, which we'll outline in a moment, with Richard, my colleague here, on inspection review. I'll pick up chemistry. Richard will pick up training. We'll then move into the thorny and interesting issue of testing and detection with Maria, with Barry McCree from Fresh Check, and myself. And then we'll close with a case study and the Q&A towards the end of that. We have a Q&A session, so you should have access to the Q&A panel. If you'd like to put any questions into the Q&A panel post as we go, that will be fantastic. That will help us to then answer any questions as we go through towards the end of the day. If somebody could just do me a little bit of a favor and just pop a hello into the, I'm going to be flooded with hellos, I know now, on the Q&A, just to make sure it actually works. I'm seeing a hand up from Lindsay Hill, which is great. That's perfect, right? We've got it. We can at least interact, which is brilliant. So, total Listeria management. Our total Listeria management philosophy is something that has been developed really to endeavour to get in front of Listeria. Too often we see that it's reactive in terms of management of Listeria. We're looking at this from the total Listeria management point of view with inspection review, so inspecting food manufacturing operations for contamination routes, vehicles, sources, and it is a critical path for resolving issues. We then move to effective chemistry for cleaning and disinfection, for training and awareness, which can be briefings or toolbox talks, and we'll talk about that later. And then rapid and effective screening for Listeria species and mono, so you've got management and control. So we are very much looking at this from a aspect of proactively managing Listeria. We will outline each of these elements as we go through today. Just so that you're aware, you will have an access to download the recording of this webinar at the end of the session. So if it doesn't come through automatically, I will make sure that we send it through to you in the coming days, along with some additional information. So in the expediency of time, I will hand over straight away to Karen, who will be talking about the current issues and legislative control. Karen, if you'd like to unmute and give us your views, that will be fantastic.
All right. Hi, everybody. Good to see so many people here from all around the world. And I'm not entirely sure everybody's so excited about this change to the EU regs, but I'll come to why that is. The issue really is of importer understanding of this and the support for them. And also for SMEs that haven't been complying with the law and other companies for the last 20 years. Anyway, so I'm Karen Goodburn, Director General of the Chilled Food Association. I run the Industry Listeria Group, which is an international grouping of trade associations, etc. And I'm the European Chilled Food Federation Rapporteur on Listeria and various other things. So I'm going to run you through Listeria and listeriosis, outbreaks and how to prevent them, what's happening with the legislation implications, what good looks like in terms of control, and the elephant in the kitchen, which is white, not grey normally. What's next for, well, where we go on this enforcement, what are the issues that need to be addressed, and then a whole stack of guidance. So I'll make sure that I've given Peter, well, I have given Peter this presentation, but make sure that there is a copy, some sort of PDF with live links, because there are a lot of live links in this presentation. Next one. Next slide.
Sorry, my cursor was in the wrong place.
It's all right. I'm not allowed to control the deck because I'm not at Chris Danes. Anyway, so a bit about CFA. I won't bang on about this, but we represent the professional chilled prepared food industry, particularly in the UK, but we don't have geographical boundaries, and we communicate best practice standards, standards of excellence, and promote them throughout the supply and distribution chain for chilled prepared food. Website is chilledfood.org, and the membership's chilled food producers only. So I'm sorry, anybody who wants to sell anything to the industry, it's not going to happen through CFA membership. Compliance with our various guidelines, which cover everything from farm to the final product. BRCGS or IFS certification. We want to see your non-compliances and your last closeouts of your last audit, and the resume or CV of the person responsible for food safety, and a reference from an existing member. So it's not as simple as sending us some money and you're in. There are standards. We're a standards-based organisation. Next slide. So onto the meat of this. I think we skipped a slide there, but I'm not particularly concerned about it. So Listeria mono will laugh in the face of salt, freezing, low pH, low oxygen. It's really tough, very inconvenient to deal with it, and what's more, if it makes your way into your food production area, it will establish itself in harbourage points, difficult to clean. Might have to disassemble the whole piece of equipment and do that on a regular basis if you really want to be sure, and clean everything broken down into pieces, and make sure you address this so it doesn't build up into a biofilm and then spread even further around the factory and contaminate your food. So it's very tough to deal with, and it has unpleasant health effects if you get monocytogenes and you're young, old, pregnant or immunocompromised. And those sort of vulnerable groups make up about 20% of certainly the UK and probably EU and also US population. So if you get Listeria monocytogenes in your food, and it's had an amplification event in particular, as Professor Martin Wiedmann refers to it in the USA, in other words, poor temperature control, then Listeria can grow rapidly. It grows twice as fast at 8 degrees than it does at 5 degrees, 3 times as fast at 10 degrees than it does at 5, and it will grow down to, well, if you look at this one, minus 4.4, which handily is about 25 Fahrenheit, because the USDA started putting that one out. Don't know how long they looked at it to see any signs of growth, but it would probably be growing extremely slowly. And certainly in the UK, our shelf lives are very short, between 2 and 10 days, which are much shorter than elsewhere in the world. And normally in the EU, we talk about -2 as a lower growth limit, so I don't quite know how the Americans got that figure and what sort of medium they've done. I've got somebody who can't get into the meeting here. Right, we can see that it's very pH tolerant, acid, and then alkali as well. Salt, cured foods don't really do anything to it, and anchovies even, it will survive. You have to think about survival as well as growth. I mean, it won't grow in a frozen food, but it will survive. So if you've got poorly controlled hygiene, say, let's pick on ice cream today, ice cream factory, and it goes out and then it's defrosting in some way or put into something like an ice cream cake, which I've had recently somewhere, and it defrosts and it's just left there, then any Listeria that's present will grow. It will grow. So you have to consider frozen food too in terms of growth as well as, of course, survival. Next slide. Right, so the morbidity and mortality, these are the latest ECDC EFSA data for Europe. It excludes the UK because we're not in the EU anymore. I will show you a slide with where not to go on holiday next. So we can see listeriosis. I've summarised that from the report. Over 2,700 confirmed cases. So that's people who've been ill enough to get doctor support and have a test result which confirms it, and then the test data makes it into the recording systems for the country. Most of these will be invasive cases. So there are two forms of the illness: invasive, which can cross the blood-brain barrier, and it gives you meningitis-type symptoms, abscesses on the brain, and, well, sepsis, basically. And also, if it crosses the placenta, and it would cause spontaneous abortions, miscarriages, stillborn, and so on. So the young, old, pregnant, immunocompromised are particularly vulnerable. So these are the invasive cases, but there's an unknown factor of how many tens or hundreds of times more are there of febrile, very mild cases that you might think, well, just a bit fluey and perhaps a bit of a gut problem. But those sort of cases aren't normally recorded. So we could have a massive multiple on the numbers of listeriosis, because it's not really dangerous to most people. And it certainly takes a hell of a lot to consume to get real issues. And there's the calculation that in the Bluebell ice cream outbreak in the USA, even though they found about 8 CFU per gram at the ice cream plant itself, that was not what people who became ill at the one hospital where they were fed the ice cream turned into a milkshake made in an uncleaned machine. There it was calculated that they were eating 10 to the power of 12, so that's a million per serving Listeria monocytogenes, and still only half a dozen people died, and they were all fed from that dirty milkshake machine. So the infective dose is very debatable, and it really depends on the status of the person eating, the health status. Europe, the cases shot up by 43% since pre-COVID, and more than doubled since 2008, which used to be 0.3 per 100,000. If you look at the case rate column, you can see it's 0.62 in 2023, which is massive. It is massive, and I can't explain it, except perhaps lots more businesses set up during COVID, and fewer enforcers around to deal with it. But certainly enforcement is a big issue with Listeria, because the rules have been in place for 20 years and nothing's changing about the basic rules. Next slide. Right, so where not to go on holiday. This is a factor of food culture, which I've split into food type, which is inherent risk, so something proteinaceous, raw, ready to eat, there's no CCP. So let's pick on cold smoked fish, for example. Listeria loves protein, so it's fish, meat, dairy products particularly are the high risk ones. So if you've got a food culture where there's a lot of that sort of consumption, and then the presentation or storage of it is not entirely chilled, shall we talk about. And I've got Finnish heritage, and you see how well the Finns do here, and the Finnish prepared food industry, my equivalents, have said to me, we're tortured by the fish because there's so much consumption of this, mainly actually raw gravad lux, and salt does nothing to Listeria, as I've already said, and having a filleted huge rainbow trout or a salmon in the fridge overnight with a bit of dill and salt in it is doing nothing for food safety, and in fact the dill's probably contaminating it as well. So you can see in cultures where food is a lot of proteinaceous food like charcuterie and smorgasbords, and the delicatessen type of cultures, and then there's big banqueting and catering, and it's left out for hours, and there's fresh egg mayo on prawns, cooked prawns at Belgian banquets I've been to, and it's out there for hours. Or my family with their Christmas cooked minced reindeer at 25 degrees all afternoon in a triple glazed house with geothermal heating. It's not going to be a good result for most people who are in a yoppie group. So I would say that's inherent risk of the food, production control as well would affect the food issue, and then the presentation and storage and the time, huge thing. And you can see the cultures reflect here. In the UK, you can see we're highlighted in green. Now, the green block is below the EU means, and since we left the EU, it's all sort of become a bit fragmented on the reporting, hence all these different figures that have come out from EFTA member states and EEA and so on. So we've got various means here, but the same 7 or 8, 9 countries that are the usual suspects and do badly or above the EU mean in terms of higher listeriosis rates, they've got these cultures where it's highly proteinaceous foods being eaten, and temperature control is questionable, and the inherent risk of the food is challenging, shall we say. But in the UK, we've got a much more mixed environment in food, and we also have these really powerful retailers who most of the chilled prepared food in this country is sold through, who demand standards, and we work with to ensure compliance. So we're normally about half the listeriosis rate in the UK as in Europe in its broadest sense, because Iceland's in here, so is Norway as well. So this, make your choices, and be careful what you eat, especially if you're a yoppie group. So we can see that Ireland is also performing as well as us, largely, if not better sometimes, because it has a similar ethos. Next slide. What makes food ready to eat? This whole list of regs that have been in place for 20 odd years. There's no real excuse. There's nothing alarming about this. Just obey the law and do the HACCP and put the PRPs in place and have the data to support the HACCP to show that you're doing it properly. The one that isn't really regulated is the second one about growing and production controls. So this would apply to, say, salad crops going into ready-to-eat food, or even the fish that gets cold smoked. There are standards for that. There is guidance for that. We've issued micro guidance for growers, 4th edition this year, and that's available from our shop. And then I have documentation on best practice in salmon smoking, and there's the European Salmon Smokers Association as well, and have guidance. So if you're in it, do it properly, or don't try, because somebody could die. Apart from that being the end of your business particularly, but somebody dying or getting ill is really tragic there. Next slide. So all these are old regulations and old requirements. Where are you, Peter? You've got this next slide. So what's happening with the law? This is for regulatory nerds. You could just write a whole book about this. But I'll just say the regulation came out. It was published 15th of November 20 years ago. It came into effect on the 5th of December 2005, and it applied from 1st of January 2026. So we've had 20 years to get it right, guys, on the shelf life. 20 years, let alone all the hygiene and stuff beforehand. And we've supported everything with a lot of guidance. I'm currently in the middle here, or just off centre above the middle line. There's 2 stars. I'm currently updating the FSA, CFA, BRC Listeria shelf life guidance, which is still very, very functional. It works, and I've had that turned into our European Federation guidance, and European Commission said in May, turn this into a European guide, but it's a bit too much work for that one. So what we're doing is not out of line with what the European Commission is expecting. We've had Codex, we've had FBO guidance, which is it's a staff working document. This is the yellow box, middle bottom. And that is being revised, and it's going to the European Commission micro working group this month. Haven't seen it. We're not a member of the EU. Hopefully we'll see it. We will be consulted on it. And somebody just commented in the chat or questions, inconsistent member states implementation is a big thing here. See, in the UK we have, well, have the issues with, shall we say, government enforcement and lack of EHOs have been given appropriate training and the right kit, sampling and swabbing kits. All of those issues apply here, but we do have these demanding retailers, which is where most of our food goes through, and they are the police force for us, not the local authorities. And different member states and competent authorities have different interpretations, so the whole thing is not being enforced, shall we say, in a consistent high standard. And then on top of this, in June 2022, the European Court of Justice said that the Estonian government did not act within the specific regulations when they tried to make a smoked fish producer in Estonia only provide food that never contained Listeria mono, which is frankly impossible unless they were going to irradiate it post-process in the pack. But that piece of law actually is what's triggered a sort of review of the European law. And is that Article 14.8, if you want to look it up, 178/2002 General Food Law applies, and that says competent authorities can do whatever they think is appropriate, even if there's no evidence of non-compliance, to protect the public. and that's a very open thing. So and that's highlighted in yellow at the bottom on that slide. If you go to the next slide there. Somebody's trying to get in the meeting as well, Peter. So what's changing on the regs? This is a chunk of Annex 1 of the regs. So this is the food safety criteria, which applies to foods when placed on the market. It does not apply to foods that are in a factory, that have not been released, put on the market. There's two definitions are placed on the market for those of us living under Brexit, and they do differ slightly. So just be careful what that means if you're in the UK. So I've crossed out the bits that have changed in criterion 1.2b. Now this one is the only change to the regs. Criterion 1.2 applies to ready-to-eat foods that can support the growth of Listeria mono, and those foods are not going to infants or for special medical purposes, so for the general population. So it's not, should we say, total diet replacement food. Okay, so here for these foods you're allowed 100 per gram maximum of Listeria. Of course, nobody wants 100 per gram, so we're all working for 0, but you can't achieve it all the time if you're actually doing sampling properly and show what you're achieving. 1.2a is the first bit. It says you can have 100 per gram as the limit if you can show that you won't exceed it. If you've done your shelf life work and you've got ongoing data streams of dairy production, end of life, and your environmental sampling to show that you are complying with HACCP and the HACCP is working and the 100 per gram is not being exceeded. And this is coupled with storage trials. The industry standard practice is storage trials at temperatures that reflect storage of the product. There are strange things going on with European guidance on this, but if you know how your chill chain works, then you can use those figures, and that's what we're doing here. If you don't have such data, then criterion 1.2b can be applied by the enforcer. This is not for the FBO to decide. It's not how it's intended. This is the penalty for not having shelf life data or supporting data to go with it, ongoing supporting data. And it used to say you would be switched on to positive release if the competent authority didn't believe you knew what you were doing with your shelf life or had data. Now that's been changed from the 1st of July next year in the EU and Northern Ireland and other jurisdictions applying EU law. And that's going to say not detected throughout life. Where you don't have data to support the shelf life will not exceed 100 per gram. It's the penalty for not complying with the law that's been in place for 20 years that is changed, and it's hardened. That's the only change. So what do you do if you're faced with this? You should get your shelf life data together. Everybody should have their shelf life data together because it's been the law for 20 years. There's just no excuse for this. The only question is, what's the competent authority going to do? And countries have different approaches. I'm aware of Benelux, and they like a bit of challenge testing, but their shelf lives are 2 or 3 times those for equivalent products in the UK. So some people have really been putting excessive shelf lives on, and they're finally being caught. Hope that's clear enough. Next slide. There's a load of footnotes that relate to this, and that's in the next slide. And it's a whole list. Don't ignore the footnotes. Don't forget the footnotes, especially enforcers, because these scope out the application of each criterion. The criterion 1.3 I didn't mention is for foods not supporting growth. There's some weird stuff in there. For example, if we look at this number 8 down the bottom with a highlighted thing, combinations of pH or AW, or products with a shelf life of less than 5 days, which is dairy production up plus no more than 4 days. That's what that is. They should automatically consider to belong to the category of not supporting growth, which has no scientific basis whatsoever. None. If you put data into predictive models or just do storage trials on something that really loves Listeria, like, let's go back to the cold smoked fish, and you put in, shall we say, 8 degrees as a fridge temperature for home, you're going to get growth within 5 days. So it supports growth and it will carry on growing. So there's some crazy stuff in this, and I believe that's just trying to keep out a lot of food service. Nothing to do with science at all. And I was involved with the regs when they first came round. So footnotes there, footnote 4 says you don't have to do testing of, for example, fresh, uncut and unprocessed fruit and veg, but there is a criterion that applies to such cut, pre-cut produce, which is for generic E. coli, and of course anything ready to eat. That has to have the Listeria compliance too. Next slide. So how do you do shelf life? Well, there's no change to what's been in the legislation for 20 years, and there's guidance out there. It's ecff.eu as a /publications, free download, and the Listeria shelf life guidance, the UK version, which I'm sort of updating just with this little change here, and updating all the URLs and references and all that sort of stuff. That's on the CFA chillfood.org/shop. Free documents. There's no restriction on getting hold of these, and they've been out for, well, the UK one's been out for nearly 2 decades. So studies, physico-chemical specs of the food, AWPH and the rest of it, all of this, potential for contamination, foreseen shelf life, that's valid. You can't make up the figures, you've got to understand what you're doing, understand PHAW and so on. Scientific literature and research data, well, we're running a big research project. We've got 5 million data points of dairy production end of life, which supports HACCP, which is at industry level and also broken down into company level. Then if you can't really show what your shelf life should be from that, then you can do predictive modelling with Combase. The problem is, even though it's free, it's very fail-safe, and it's going to get more fail-safe because we understand that there's moves to take out the default lag phase from the model, which will have possibly a serious effect on shelf life, and certainly in the chilled food in the cold factory with biocides, because we're using hygiene products, then that would really compromise the ability of organisms to grow. So we've got a big question about how relevant Combase will be in the future. Or you can do some challenge testing, which is exactly the opposite of what we do in the food industry, which is putting a high number of log phase, rapidly growing, really fast growing strains and mixtures of strains, and putting them in and saying, oh, look, it grows. Well, our whole job in the food industry is to keep food clean, which is just the opposite of sticking a load of organisms in. I've got a whole slide ranting about that, which I won't go on about in detail, but leave for you to digest. There's no expectation of the European Commission or anyone in that level of authority, certainly in the UK, to do any challenge testing, and there is no impetus to do so now. Just get your shelf life data together and do studies to evaluate growth and survival. Storage trials. Do the storage trials and continue to collect dairy production, end of life sampling data and hygiene data. Next slide.
Karen, before we move on to the next slide, can I just ask for people on the webinar if you could avoid, please, changing the language settings in the thing, because we don't want to suddenly turn Karen into talking something strange. So I've got a request at the moment for somebody to I've been ignoring a few requests to change language. So if you could please not change the language settings at your end, we'd appreciate it. Sorry, Karen.
All right. Next slide. So the next slide is, these are notes agreed with the European Commission from a meeting I set up with European federations and the Commission on the 6th of May with the team, the lead on the microcriteria regs and his boss. I'm just going to put this out here, and this is agreed minutes of a meeting. So if there's any doubt at all, please refer to this. What I am waiting for, what we're all waiting for, is a revision to the document mentioned in point 3 here, which is the 2013 FBO Shelf Life Guidance, which is a staff working document, not official. It's been given to the European Reference Lab on Listeria to review. And we're assured by the Commission they're not going to change anything, because the law is the law and nothing's changed in the law. Except I'm a bit concerned because last time the reference lab was given something to do, they went all challenge testing on everybody. So we'll have to see what happens there. But the law is the law, and it's up to member states to decide how to do shelf life. Next slide. So I've got a bit of intelligence about other things. I already mentioned Belgium and the Netherlands, which is down at the bottom here. So they're saying to companies, and have been saying for the last 5 years, especially after a fatal outbreak of cooked sliced meat product, should challenge test the worst case of the products in the FBO's range, and they've had to cut shelf life by a bigger amount, quite a big amount. But as I said at the top, our shelf lives in the UK are much, much shorter for equivalent foods than those in continental Europe. So there's something weird going on about acceptability. And I certainly know that the shelf life for cold smoked fish, again, is in the scale of months, several months, when it will be weeks here. And that's just commercial demands, not based on validated shelf life. Ireland we understand they're not going to require challenge testing because it's not required by law, and it doesn't help you clean your factory, which is a main source of contamination and compromised shelf life. Also, I mentioned if Combase, they put in zero logs if you've got a consistent stream of data that shows non-detection. Not as a rule, if you're finding Listeria, countable Listeria, you've got a problem. You have a problem and it needs to be sorted out. It could be the supplier of a cooked meat going into a sandwich or whatever, and or your own factory, but it needs to be sorted out. Lag time, FSA Ireland is saying ignore it, and then we've got the concern about Combase having it removed as a default setting. And then temperature, they have their own approach on that shelf life, how to do the storage trials, what temperature. And they're saying 10 degrees for a fridge at home, which is really exceptional. The way we do it is up to dispatch, and in the secure chill chain, which is all the way to the back of the retailer's store, the multiple retailers, through their regional distribution centre and so on, 5 degrees Celsius. Then the legislation here says 8, but nobody's running at that because it compromises shelf life, and this is in the professional big retail chains. And then we're doing 7 plus or minus 1 degrees to represent sale, and 22 degrees for taking it home for 2 hours bursts, and then another 7-ish for I think I've written 8 degrees, about 8 for the refrigeration at home. And then FSAI will be sampling on the market using the enumeration method, which I'll come to. Next slide. Next slide is what we got. Challenge test rate. It is not required by anyone. I understand that we've got EHOs in this country who nobody has had training on this for 6 years. There will be training of enforcers in Northern Ireland this autumn, and certainly in the specification for the training there's no saying you must do challenge testing. There's none of that, and this is just people are doing it because they're running scared, and there's a lot of hype on the internet, particularly on LinkedIn, about you need to do a lot of testing that you never did before, which is not true. You just need to have a basis for your shelf life. So that's just to note. Next slide. So the implications of the change penalty, well, should have been complying with the law for 20 years. So I have not a lot of sympathy, but the only question is what are the enforcers going to do, especially if they haven't had training. So my concern really is that FBOs that are not doing best practice or even complying with the law are going to carry on until somebody catches them and they're enforced against. And in the meeting with the European Commission, they said that it's really the SMEs that they're mainly concerned about, who lacking the technical resources that big companies have. They're the ones they want to get. But if you're put on to criterion 1.2b for a food that's ready to eat and supports the growth of Listeria, and because you haven't got data that is acceptable, then you can either reformulate, which will possibly make your food inedible because the pH would have to be so low to kill LM. It's not about stopping growth, it's about not having it detectable throughout life. Or you can shorten your shelf life to less than 5 days, which would mean it would technically, well, according to law, not support growth, but that really isn't, as I said, a safety measure. It doesn't work. You still have to have your data. Or you can process in the pack, which would also mean that criterion 1.3 would apply, or do something else. We can't put bacteriophage on products of animal origin, but the main thing is get your data together and get out of that enforcement loop and have it all ready, lined up as day of production, end of life, environment, and so on. So and then make 1.28 applicable. There's another little bit on the bottom of this. One concern is that this is already happening and has been happening for years, particularly on the continent, in spot checks on the market, and you see this in RASFs as well. The competent authorities are taking a sample saying, well, we don't know if the shelf life is valid, so we're going to say this needs to be recalled. And that's really based on detection of the hazard organism, not on the quantification, and the law is about a quantitative limit. So there's that application 1.2b, and I've raised this with the Commission. How will somebody know by looking at the label whether the shelf life's valid? And it stumped them a little bit, and they said, well, we share information very quickly. but not for, I challenged them on the short shelf life of 2 to 10 days, and they had to accept that probably wouldn't get that information very quickly. So that's an issue there. So what we need, get your shelf life data together. Get it together. You should already have it, and carry on taking your stream of samples, dairy production, end of life with the environmental controls, and suppliers of high-risk food, the fish, meat, dairy, they need to comply with all this as well. But we need much more emphasis on environmental controls and active management and enforcement. So we've issued this environmental management programme guidance, of which there is also a European Chilled Food Federation version, ecff.eu. Next slide. And that tells you how to go about things, how to swab and how to trend data. The law says very specific things. You must sample the production environment for Listeria mono where it is presents a risk to the food. You must trend the data and act without undue delay on adverse trends, and the same applies to the food sampling. So what we're working for here is to ensure that this best practice approach that I keep on going on about the shelf life trials and all the data, that is recognised, and the European Commission is happy with that. As I said, it's referred to in various documents in FSA, and Scotland and Ireland, and I mentioned the European document as well. But the big thing is that in this country, certainly, and I believe elsewhere, enforcers require support, and they need to be trained and have the resources to do the job. You need to catch the people who are not doing the right thing. Next slide. So what does good look like? Well, we've got this data set of 5 million data points from 2004 for food, and then we added in production environment sampling in 2006. So more than 20 years worth of data, and this is from our members. The members are listed on our website if you're interested. So for the last 12 years, because that's all we could fit on the screen, 1.1 million food samples, and we had 149 countable Listerias. That's it. And most of it is not quantifiable at all, if it's there at all. We've split it into raw, cooked and mixed component foods as well. So we got a lot of granularity here. You can see what each company is doing and the data collected on a monthly basis. And we use that to benchmark companies, and then they're required to respond to a letter even if they're 0.01% above the CFA norm for any category of food, or the production environment as well. So over the 12-year period up to the end of last year, it was 2.2 million samples. And we split it into food contact surfaces during production and post-hygiene, and also non-food contact. So we can see that there's pretty much a tenfold difference between food contact and non-food contact. Non-food contact, looking in drains is the first place you should look as an enforcer. And what else do I want to say about that one? So a lot of data, and we split it into high care and high risk as well. A lot of data to support HACCP. Next slide. So what we're going to do in the UK, we've got Brexit, and under the Windsor framework, EU law applies directly in Northern Ireland, but as I mentioned, FSA Northern Ireland preparing to train EHOs this autumn. There's no change in enforcement approach at all. But the question is, how do you handle a non-compliant business that might have been going for years or decades, and they just haven't done shelf life work? They've just looked at a comparable product in a major retail store, for example. For companies trading with Northern Ireland, well, you've got to carry on as usual and have a sound basis for shelf life. And that's been required by law for 20 years. And I'm advising any retailers who come to me who are concerned, or anybody who's concerned, to say, make sure your customers in Northern Ireland are aware of what you've done and how you comply with the law. In Great Britain, that's the rest of the UK, apart from Northern Ireland, well, we've got overall a better listeriosis rate performance than the EU, and the UK government has expressed confidence in our approach. We've got agreement to have an agreement on SPS and trade with the EU, which that's not been done yet. It's not going to start negotiations till autumn, and it looks like we'll have dynamic alignment, which means adopting EU law as it comes along, but without having a say. So we don't quite know what's going to happen, but we just need to make sure that the best practice approach for shelf life that we're doing is acceptable to EHOs, which is a bit I'm working on particularly. So I'll carry on. I'm just saying, carry on as now if you're doing best practice. Discuss it with your enforcer, discuss it with your customer, And whatever your national authority is, they may have special rules like the Belgians and the Dutch, but otherwise just get the basis for your shelf life sorted out. Next slide. We'll whip through this next bit. So why do I mention environmental management programs? Because when you look at the major fatal listeriosis outbreaks and root causes, which were analysed by the FAO, the Food and Agriculture Organization of the United Nations, in the report linked at the bottom, it's post-process contamination. That's the big one. So you've cooked the product, or whatever you've done to the product, and then you contaminated it from the environment. So you've got to manage this. You've got to manage this. It's a well-known fact that environmental contamination, because Listeria is an environmental organism, is how things mainly go wrong, all the way through to the South African outbreak with the Tiger Brands food, which killed 216 people that we know of. Next slide. And then in the UK, and I think elsewhere, because there's some stuff with hospital, well, I mentioned the Bluebell ice cream in the USA, and there's another hospital catered food which has a listeriosis outbreak. If you hit the next slide thing again, I think you should get. You see, hospital sandwiches, they're the primary source of UK listeriosis cases and clusters going back 20 years. Of course, there have been more since 2019, but nothing quite on the scale of the 2019 outbreak. And there, the cooked diced chicken sold by the preparing company to the sandwich producer had 1,000 CFU per gram. Yet, the enforcer thought they were doing okay. Well, I don't think they sampled the food or looked at any data. So there are big issues in hospital thing, because of course we got the young, the old, the pregnant and the immunocompromised all in hospital eating these sort of foods, ready to eat foods, and there's no real chill chain when you get to the hospital patient's bedside. So it's the worst combination of factors possible. Next slide. So looking at the hospital sandwiches, how well it was managed, the preventative controls, and then we had the UK and EU frozen maize outbreak. People were eating it thawed. I don't know what they were doing with that, but certainly my mother used to put frozen peas in salads, and I'm probably lucky to be here, but at least it was in a pod, I suppose, not open to the environment. So the hospital sandwiches, a tick would be good all the way down here, and you get 10 out of 10 points, plus 10. And only one thing was okay, which ironically the end product had a short shelf life, but it doesn't really help you if there's 1,000 per gram in the filling. It's all compromised all the way through, really, apart from end product had a shortish shelf life. But then it was temperature abuse at the bedside. The frozen maize, well, it wasn't chilled, but it was eaten thawed, so that negates that, really. Chilled chain, cold chain, that was assured, but it was eaten thawed, not cooked. We don't know whether the people who died were in vulnerable groups or not, and so for each of those are given -9 out of +10 to the hospital sandwiches control, and then the frozen maize -7. So I think we're coming to the end of this. Next slide. So we need to make sure that enforcers are aware of what the law is and what good looks like. That's a big deal. As I mentioned, there are only 4 things the regs really require for Listeria, which is your production area sample for mono, and you trend the data, so it's not just one data point now and then. On average, CFA members last year contributed 3,000 factory environment swabs per site into our database. 3,000 per site. And 2,000 food samples per site last year. So that's the extent of sampling going on across our membership. That's the average. The regs also require adverse trends to be acted on without undue delay. And then shelf life has to have a sound basis. And I've just put in the shelf life guidance there. So I've developed an enforcer briefing note setting out their powers. And then also another briefing note for businesses saying what you need to do to comply, and signposting to resources. Next slide. This is just, you can have this, just have this later, but this is the impact of a Listeria species, not even monocytogenies, being detected on the raw ready-to-eat component going into a sandwich factory. And so in blue is all the measures, the proactive measures in place to assure safety, and then the action in red in pinks is what you do on finding a Listeria species positive, not even mono. There are 28 species of Listeria, and only one is monocytogenes, which is proven to be a human pathogen. Most of the strains are. The rest are really environmental. They just show that you've got some part of the environment in your factory, which of course you will do if you put food in it. And it takes, really, in this example of finding Listeria species positive on, say, a salad going into a sandwich, it takes one person months of work to deal with it. And because all detections are investigated and addressed back to the supply chain, and also dealing with the customer, the retail customer. Next slide. Fridges, survey data, more recent stuff from the UK. It was shall we say, not a professional thermometer that was handed out at a festival for people to put in the fridge door, which is the warmest part, but those are the data. 29% of fridges were reported to be at 5 or below, and the rest were not. And there's some really high. There was one running at 20 degrees, which is actually an incubator and not a fridge. Netherlands also did a study recently. It is the elephant in the room. And I've set up a project with the Food Safety Research Network here, FSRN, looking at design performance and usage project, which is ongoing. Next slide. So what's next? HACCP. Is your HACCP working and you've got all the data to support it? Have you documented the shelf life basis of your LM risk products, irrespective of the criteria? You have to have it. I'm saying day of production end of life data to support the original shelf life testing. Usage instructions labelled correctly. A lot of work done by the frozen industry after the frozen maize outbreak, saying cook this. And are we going to adopt the law? Not known, but really it should be business as usual, as long as the enforcement community understands that nothing has changed and best practice is best practice still. I'd really like to see bacteriophage permitted for products of animal origin. We need to sort out the fridges. Then the big thing for me is, why do we keep having incidents? Well, it is difficult with a raw ready-to-eat food because there's no CCP. There's no kill step. But otherwise, let's sort this out, please. I've been talking about it for 30 odd years now, and the same thing keeps on popping up now and then, because a lot of it lacks enforcement, and for us in the UK it's commercial enforcement by the retail customers of the O-label food that is really critical and missing elsewhere, I'd say globally. And then last but one slide is actually a whole list of guidance. Next slide, Peter. Massive amount of guidance with live links there. It's government, it's industry, it's all sorts of stuff in there. So please, take it away, digest it, and apply it if you're not already. And that's it. I think I managed to do that in slightly more than 40 minutes. I'll have a look at the questions now and see what's popped up.
That was fantastic. Thank you, Cara. That is brilliant. We're just going to switch over now. Excuse me with the cursor moving around on the screen. I'm splitting between two screens to manage things. So it's now going to hand over to my colleague, Richard Cowdroy, who will talk us through inspection and review.
Good afternoon, everyone. As Pete says, I'm Richard Cowdroy. I'm the UK Technical Support Manager for Chris Daines Food Hygiene in the UK and Ireland. My primary function really is about the practical application of chemicals within our food processing sites, dairies, beverage processors as well. And I'll often find myself getting involved with discussions with our customers regarding their Listeria management and control plans. And it always amazes me just how reactive these plans are. And that's really where the total Listeria management program has come from, really trying to flip that reactivity into a more proactive approach. So the first thing we were looking at in this total Listeria management plan is the inspection and review. So looking at the key checkpoints, around the environment, starting with surfaces and structures. So ceilings, walls, doors, floors and drains, understanding what these surfaces are actually fabricated from and just how cleanable they are. In most modern facilities, we'll see white cladded walls, which, from a hygienic point of view, are very easy to clean. But we often see that these are compromised in some way, whether that be through accidental impacts, through the movement of process equipment, or through engineering work. We often see where the surface has been compromised, where maybe a support frame has been on the wall, it's been taken away, and we still see holes drilled in the side of that. Now you've got to bear in mind that these cladded walls do have insulation within them, which is absorbent. So if they do get wet, they can harbour bacteria as well. So it's checking the condition of these surfaces as well, making sure there's no damage to them. Again, cracks and crevices can harbour bacteria. So it's making sure that these surfaces are cleanable and accessible as well. So the cleaning practices that you employ, have you assessed the frequency that you need to clean these surfaces? We'd always advise that a risk assessment be carried out on this, understanding just how susceptible these surfaces are to contamination through the general process that you carry out. You can lean on experience from your hygiene team, your hygiene management to support that as well. But that risk assessment is a key and integral part of establishing just how frequently these surfaces need to be cleaned. Understanding what type of clean are we carrying out? Is it going to be into product changes during production, or a full hygiene window clean following a production day? And it's making sure, obviously, that people who are carrying out this clean are suitably trained as well. When it comes to dismantling equipment, it's scheduling these things in as well. We will have our sort of daily, weekly cleans that will generally be carried out without the support of engineers. However, surfaces behind panels, hard to reach surfaces, which will require engineer involvement, that needs to be scheduled in with the engineering team as well, and making sure that they have the resource to supply to the hygiene team to make sure these panels and surfaces can be reached. From a chemical point of view, it's making sure that we do have the right chemical for the job, okay, and making sure that chemical is applied correctly and at the right concentration as well. Now, from my experience, coming from a hygiene background, it was always the hygiene team, that was sort of criticised in a way, really, if there was any issues on site. The cleaning's failed, something's gone wrong with the clean, the chemicals aren't working properly. But really, we also need to consider, the flow of the process as well, making sure that, the layout of the factory lends itself to make sure that we're not compromising food safety just through the general process that we are carrying out. Making sure all systems are safe and validated. That goes for cleaning processes as well, making sure everything that we do from a hygiene perspective is verified and validated ongoing. Delving a little bit deeper now into the structural side of things, we're looking at weld quality. Primarily, we'll see issues with welding on CIP systems, but bearing in mind that the majority of food processing equipment will have some sort of welding on it as well, whether that be as part of the initial fabrication of the equipment or due to engineering, site engineers carrying out fabrication work or changes to the equipment as well. So obviously, any poor weld leads to a surface that isn't smooth, which again can harbour bacteria and contamination. Looking for stress cracks and fractures in the equipment. Okay, a lot of the equipment we utilise will come under a lot of stress through the movement of the actual equipment, conveyors, motors, things like that. So it's making sure that we're regularly checking for any damage from that point of view. Dead legs and unused pipework, particularly again relating to CIP. Corrosion, okay, monitoring for rust and degradation, again leading to a surface that isn't smooth, which can harbour bacteria and contamination, but also can lead to physical contamination as well. Making sure that we're avoiding mixed alloys. We see a lot of process equipment which is predominantly stainless steel, but there'll be certain surfaces which are maybe made from a different metal, whether it be sort of soft metals or something that's susceptible to more corrosion. So again, it's understanding how the chemistry may need to change relating to that as well, or the process may need to change to make sure that we're not compromising those surfaces which are susceptible to corrosion. Surface damage, again, maybe just through accidental dents or scratches, or it might just be through general wear and tear. So it's making sure, again, that while your hygiene crew and hygiene team are operating, it's making sure that they're checking the equipment's integrity as well and reporting any damage that can be corrected, so there's no issues caused there. Any hidden areas, crevices, conduits, so conduits that supply facilities, electrical, water, air, to equipment. It's making sure that these are designed hygienically and accessible for cleaning as well, and also making sure that, you know, we're not allowing our engineering team to carry out temporary fixes. We call it sellotape engineering, really. So it's making sure that any engineering work is carried out to a high standard and in a way that's not going to compromise food safety in any way. So back to basics, really, when it comes to hand hygiene. You know, we learned a lot about hand hygiene around 2020 during the COVID pandemic, and it was one of my sort of things that I thought was going to be a lasting legacy of that time, that everyone's going to be really conscious and aware of just how important hand hygiene is. And I think we learned a lot from that period about, you know, transmission of viruses and bacteria between people. But it's also from a food safety point of view, it's really reinforcing the importance of it to ensure product safety on the process sites as well. Mentioned before about process flow, you know, making sure that, you know, that there's nothing happening within your process which is going to compromise food safety in any way. Everything that may be transferred from high care into packing and from low care into high care, there's no way that there's any these things can be compromised through the actual general process of your production. During floor cleaning, obviously avoid any hosing where possible and use squeegees to minimize sort of any aerosols which can be created. From a staff point of view, ensuring that the hygiene tasks are supervised. You know, correct supervision and management is really important. We see a lot of turnover in hygiene staff, so training and awareness is an important thing, which we'll cover off later in the presentation. But making sure that there is the presence of supervisors, team leaders and management during cleaning as well is a really important thing. Segregation and flow. Particularly in washrooms, making sure there's a clearly defined route in for contaminated and soiled equipment. And obviously, once it's been cleaned and decontaminated, that it's stored in a way which isn't going to be recontaminated by the cleaning practices that you are carrying out. So I mentioned just before about correct training. It's making sure that documented procedures are trained to the operatives, and these things are regularly reviewed from a finished standards point of view, and making sure that the staff are continuously monitored by management as well. Floor hygiene, again, just making sure that no equipment, when dismantled, is actually placed onto the floor. We often see mobile tables used, plastic pallets. Plastic pallets, again, a bit of a contentious issue, bearing in mind the proximity that they do actually still have to the floor. So if they're not actually being removed from the area fully, just bear in mind that plastic pallets, you know, probably aren't quite as suitable and do leave the equipment surfaces susceptible to contamination as well. PPE, you know, making sure that during production that the staff are wearing PPE to protect the product, but also during cleaning, obviously, to protect themselves as well. Positive release methods, again, making sure that any handover from hygiene into production takes place and that production are happy with the standard that the factory has been left in and they're ready to start production. But also consider the handover from production to hygiene of an evening or whenever your hygiene window is, making sure that the hygiene team are, you know, given a good head start and are happy with the condition that production are leaving the site in as well. From a disinfection point of view, it's making sure that we are using the right chemical, and obviously the strength of that chemical is suitable for the application that we're carrying out. If we are using a soak method for disinfection, it's making sure that all items are cleaned and fully submerged as well. But also from a validation and verification point of view, it's making sure that obviously all these documented procedures that we have in place are validated and continuously verified ongoing as well, using some of the various techniques which we'll discuss later in the presentation as well. So where we see the key parts of total Listeria management, it really is the planning, making sure that, you know, cleaning is scheduled in. If there's any additional resource required from engineers or elsewhere, that this is planned in and everyone is aware of the tasks that are involved. Preparing, Okay, making sure again that we're fully prepared for every eventuality. You know, it's great when production runs to plan and we have our full window for hygiene practices to be carried out, but making sure that we are prepared for any eventuality should production overrun and that window be compromised in any way. Making sure we document everything we're doing. So methodology is documented and trained out to our operatives as well. And those training records are documented and kept up to date, but obviously documenting any corrective action that we do for future reference as well. But the important thing is to act on the indications that we're getting from our environmental monitoring, just to make sure that we are producing good quality, safe food. Okay, I'm just going to hand you over to Peter now.
Brilliant. Thank you there, Richard. So we're going to talk, we're rolling rapidly towards a break for about 5 or 10 minutes, just to give you a chance to stretch your legs. We're going to talk a little about chemistry for removal of Listeria and where cleaning and disinfection, cleaning particularly, fits in. Listeria control is really more about cleaning than disinfection. And if you're using a proper validated cleaning regime, just as Karen was talking about earlier, you'll save yourself a whole world of pain and it will become so much easier. So cleaning is about the control. The challenge can sometimes be accessing that reservoir or that population. And that can be a factor of design, of fabrication, or of simply getting to the piece of kit. You know, if it's a high level conveyor, getting access to it can be a challenge. The key thing to do is talk to your hygiene teams and say, where's difficult to get to? Because they'll tell you, because they're trying to get to it. So engage with those teams because they'll be able to help you. And whilst when we're talking about cleaning being critical, it's to do a lot with occlusion. So if you've got a solution or pooling of water, and you've got organic debris, which is shown by the green on the screen here, as opposed to the disinfectant particles that are shown by blue. If you've got lots of debris because you haven't cleaned properly, you're going to struggle to actually get the disinfectant to your Listeria, to your bacterium. One of the failings in our industry, and we are working on it, is to equip our biocidal active molecules with GPS and an outboard motor so that they know they can head for the bacteria rather than just bubbling around in solution, bumping into something organic, binding with it, and hopefully it's a bacteria. If it is, fantastic. If it's not, it's wasted. The same happens with surface occlusion, particularly where you have defects or you have damage to equipment surfaces. As you can see in the graphic there, you've got the bacterium hiding nicely in its little crevice, tucked away behind a load of organic debris, and that biocidal disinfectant particle has got no chance of reaching it. So if you are stuck for time, there is always a temptation to just quickly do a quick wipe over and then whack a load of biocide on, whack a load of disinfectant on, and hope for the best. You're better spending your time doing a good clean to get rid of the bacteria and actually get rid of the debris, and that will take a lot of the bacteria with it. So that's why we say that Listeria control and management is more about the cleaning than the disinfection. It's about the time, it's about the effort, it's following the properly validated cleaning instructions, as Richard was talking about a few moments ago. If a biofilm is present, and we'll look at biofilms in a moment, then additional stages may be required in that sequence of clean to safely and effectively remove that. I'll explain what I mean by safely in a moment or two. And it's worth remembering that despite the problems that this bacterium causes, and despite the danger it presents, it's actually a weakling. It's very, very easy to kill Listeria. If you can access it, you can get some biocide on it, you'll kill it. Okay, it's a gram-positive, so it's got quite an absorbent cell wall, and we can get the disinfectant inside and rip it apart and disrupt its metabolic and reproductive processes relatively easily. Bear in mind as well, Listeria can be tricksy. it can enter a viable but non-culturable state, which means it's still alive, it can still cause infection, but it won't grow in the lab. And anybody who's tried to grow Listeria in the lab, and I'm sure Maria is grinning at this point, will know that sometimes it just doesn't want to grow. You know, you can have some great conditions, but it won't grow. Yet put it in a human body or in a food factory, and we're away. So there's not much to say on the chemistry for removal section because it's about basic cleaning. It's about standards. It's about access. It's about fabrication. When we start looking at biofilms, and those of you that have dealt with biofilms will know that 80% of that biofilm mass is actually the EPS layer. So there's very little bacteria in a biofilm. The majority of it is inorganic material. And that forms a protective barrier around the biofilm, which makes it quite difficult to remove. Now, Listeria will start to form a biofilm. It is a primary colonizer. And what you will find with a biofilm once it's matured and formed is it will break off particles, it will break off bits and give you random spikes or peaks in your environmental monitoring. And if you don't remove it carefully and safely, then you will experience a blip for a few days where your micro results will go up before they come down because you've just released a big micro population. We could do a whole different webinar, and we may well do, on biofilm control because it is something that is absolutely fascinating. But only to those of us that like playing with bugs. Most of the people in Christanes like to find the bacteria and kill them. Some of us like to grow them. Now, when you're looking for a biofilm, there are two methods of detection. There's a spray you can use which relies on decomposition of hydrogen peroxide by the enzyme catalase, which catalase positive bacteria will produce. But that relies on bacterial metabolism within the biofilm. And quite often, because nutrients are being swept through the biofilm structure towards the bacteria, they're actually quite inactive and dormant sitting in that biofilm. So you have an increased chance of false negatives. Alternatively, you can stain the EPS layer. Now, if you recall, that EPS layer is roughly 80% of the total biofilm mass. So you actually have a clearer and easier identification of the biofilm. Independent on bacterial activity, we're just staining the inorganic material. And as you can see on the screen there, we've got the pink spray has been applied in the top graphic and is then rinsed off. And you can see the pink staining on the damaged fabrication there, which is indicative of a biofilm that's built up on that surface and could potentially give you contamination. So it's an easy visual indicator. The other fantastic thing about this way is it stays pink until you remove the biofilm. So if a factory complains that you've turned bits of their factory pink, get rid of the color. No, get rid of the biofilm. The pink will go with it. The biofilms are now a lot easier to detect, to identify, and to remove using specific products. We're now on 10 past 12 here in the UK, 10 past 1 in most parts of Europe. And if you're further afield, then it's 10 past or 8 minutes past, whatever your hour is. We will take a short break just to give you a chance to get up, stretch your legs. If you're quick, make a cup of coffee or a cup of tea, and we'll get a glass of water, and we will reconvene at 18 minutes past the hour, please. So we will start again very shortly. If you have any questions, if I can just remind you to either, we seem to be split, we're either putting them in the chat or the Q&A, either will work, we have access to both, but just pop your questions in there, and then we'll pick them up as we get to the afternoon.
Okay, just another minute or so before we start again, guys. You're going to get yourselves comfortable. Okay, so welcome back. I've enjoyed your short break there. We discussed earlier about this changing of philosophy from this sort of reactive approach to Listeria management and control and making it more of a proactive approach. And it's really training and awareness that can help with that change. Now, we discussed the importance of training against cleaning methodology and good hygiene practices. But really, it's the training and awareness of your teams which can play a key part in that transition as well. So really what this is about, it's tuning in your teams to be looking out for things within the environment, within the process, within the practices that are happening within your factories to make sure that we are actually actively and continuously monitoring what is happening. So from a management and supervisory level point of view, it's getting them to understand what legislative requirements are there, what the individual retailer code of practices are saying in terms of requirements, but understanding what the consequences of failure to achieve those standards is as well. Not only that, looking at the conditions that Listeria requires to grow and the common reservoirs and vectors that it requires, so they can continuously monitor and check those as well, just during their day-to-day tasks. Testing and detection, so what actual methods are available. I know Maria is going to go into a lot more detail on that later, but also looking at the elimination and removal. I know Peter's just discussed the chemistry required and the importance of the actual cleaning side and not just relying on disinfection as well. So it's making sure that everyone understands what is required from that point of view. But in general, it's just making sure that good hygiene practices and good manufacturing practices are achieved and monitored and maintained as well. From an operative level, okay, probably the most important people, there's generally more operatives than management on site. So these are the people who can really see what is going on a day-to-day basis. Toolbox talks are a fantastic way to get engagement from them. So sort of 10, 15 minutes sort of talks on the shop floor, getting them to walk the site with you and to identify where these areas are that could be susceptible or sort of issues with the process that may be happening, get them to feed that back to you, this nearly happened or that nearly happened, or we've noticed this information is absolutely critical and vital as well. So again, from their point of view, it's all about good hygiene practices, good manufacturing practices, just making sure they're conducting themselves in a way which isn't going to compromise food safety or lead to transmission of Listeria around the environment as well. But also things that can be placed on the wall, infographics, posters, highlighting how, detrimental Listeria can be and, how significant things like the mortality rates that Karen talked about before, it's getting them to really buy in, supposed to scare tactics, shock tactics, whatever you want to call them really. But it's just making sure that everyone is engaged in some way in the fight to manage and control Listeria. Okay, I'm going to hand you over to Maria now, who's going to talk about testing and detection.
Maria, you're on mute.
Now, hi, good afternoon. Hi, good afternoon to everyone. I am Maria, and we are going to continue explaining the detection methods to detect Listeria. A slide, please.
You have control, Maria, so you should be able to move it forwards. Yep.
Now, okay.
That's you.
So nowadays, we have different methods available in the market. We can use traditional microbiology. We can select selective culture swaps, or we can use the molecular biology techniques like PCR or DNA sequencing. The first one is the traditional microbiology. As you know, we have media to grow microorganisms in the laboratory in plates. And the workflow is very easy. We take the sample from a surface using a swab or wipe. Then when the sample arrives to the laboratory, we make a dilution in peptone water, and then we homogenize the sample with the peptone water. After that, we do a serial dilution and we plate counting with selective media in plates. These plates are incubated at specific temperature during the specific time, and after the incubation, we count the cells. It's important to emphasize that with this type of methodology, we can quantify. We are detecting viable cells and we can quantify them. We quantify them in colony forming units per milliliter or per square centimeter. As you can see in the screen, we have a specific media to detect Listeria. In this case, it's a selective media called ALOA, and in this media, we can identify species of Listeria because we obtain blue colonies. Also, we can differentiate if it is Listeria monocytogenes or it is another species of Listeria, because Listeria monocytogenes has also an halo surrounding the blue colony. So the traditional microbiology, of course, requires a microbiology lab. We need a microbiology lab because we need to sterilize all the material, and also we need to prepare media and incubate and count the colonies. So we need a microbiology laboratory, and also we need technicians with microbiology training. Also, we need to incubate to do the plate count, and we need time for this, 1 or 2 days. And what we are detecting with this method is the viable cells, viable and culturable cells, and we are able to count them. Also, we have another option. It is the selective culture swabs. In this case, we use swabs like this Hygiena Insight test that you can see in the screen. In this case, we use a swab for sampling from the surface, and then we put this swab inside of a tube. Then we incubate this tube, and after the incubation, we can see color changing if we have Listeria species. This methodology not requires a laboratory, microbiological laboratory, because we don't need anything. It is very easy to use. You can do, everyone can do it, and we can do it in situ. Need a laboratory. Also, we don't need a specific training. Everyone can do it, and we need time because we need to incubate. The only thing that we need is an incubator to incubate the tubes. When we put the swab inside of the tube we have chromogenic liquid with antibiotics, with growth enhancers, and with color-changing compounds. All of these ingredients favors the growth of Listeria species and avoid the growth of other bacteria. So during the incubation, we favor the growth of Listeria species, and after the incubation, we can see the color changing if we have Listeria. Another option is the PCR. The PCR, everyone knows this technology. After the COVID pandemic, the PCR is a molecular biology technique, and it is able to detect presence or absence of Listeria. We can detect Listeria spp or Listeria monocytogenes because there are 2 types of kits. We can choose the kit of Listeria spp or the kit of Listeria monocytogenes, depending on what we need to know. The methodology is the first step is sampling using a swab or wipe. And after that, when the sample arrives to the laboratory, we do a pre-enrichment. We do a pre-enrichment with a specific broth for Listeria to select to favor the Listeria growth. We do the pre-enrichment during 1 day at specific optimal temperature, and after that we do the lysis and then the amplification. And if we have a positive result, we need to confirm by plate count. So as I said, the first step is sampling, then we do the lysis. During the lysis, we use a thermocycler, and the objective of the lysis is to break the cell and go outside the DNA. After that, we amplify a specific region of the DNA. During the amplification, we do 3 steps: the denaturation, annealing, and elongation. And these 3 steps is repeating multiple times in order to obtain multiple copies of the specific fragment that allows us to identify Listeria. After that, we have a positive or negative result. So to do a PCR, we need a microbiology lab with molecular biology equipment. Also, we need specialized technicians with molecular biology knowledge. We need time to do the pre-enrichment, and we are able to detect viable and not viable bacteria because we are focusing on the DNA. So if we have a negative result, it is okay, but if we obtain a positive result with PCR, we need to confirm the viability of this microorganism, of this Listeria, by doing a plate count in selective media, like in the traditional microbiology. Sorry. I can't go back. Now. And the last methodology is the DNA sequencing. The DNA sequencing, in the DNA sequencing, we have 2 options. We can do a 16S analysis, or we can do a whole genome sequencing. If we choose the 16S analysis, we can identify the metataxonomy. I mean, metataxonomy is identify all microorganisms in an environmental sample. So we take the sample using a swab, and then in the laboratory, we do the DNA extraction. We extract the DNA we break the cells, we extract the DNA, and then we do the amplification. After the amplification, we make libraries, and then we do the sequencing. To understand this technology, it's important to review that the bacterial genome has only 1 chromosome. It's a circular chromosome, and there are only 1. But we are not interested in the whole genome. We are interested only in 1 region. Why? Because in this region is the specific area of the DNA that encodes for the 16S subunit of the ribosomic RNA. And this region is interesting for us because in this region we have common regions that are common for all bacteria, and also we have 9 variable regions that allows us to identify each bacteria. So with this kind of analysis, we can identify all bacteria in a sample. In this kind of analysis, we take the sample, we do the DNA extraction, and then we make libraries. Then we do the sequencing, and then we need to do a bioinformatic analysis. For this bioinformatic analysis, we need a specific PC with specific requirements, and also we need technicians with training in this kind of data analysis, because it's tricky to analyze this kind of results, and we need to be sure that we are we are making the correct conclusions. So the DNA sequencing, the 16S analysis, allows us to identify all microorganisms in a sample. So in this case, we obtain a large amount of data, and we not only detect Listeria, we detect all microorganisms. And it's possible that we identify some microorganisms that we don't know, because there are a lot of microorganisms that nobody knows because they are not in any regulation, in any standard, so nobody looks for them. But they can have an important role because they can be biofilm-forming microorganisms, for example. And if they are able to form a biofilm, Listeria normally reach biofilm previously formed and set up inside, and use this biofilm to protect them for the environmental conditions. So in this case, this kind of analysis allows us to identify everything, and with this information, we can have much more control about the microbial ecology of our food industry. Also, this kind of analysis allows us to classify, to obtain the taxonomic classification of microorganisms until the level of genus or species, and we are able to identify viable and not viable, or culturable and non-culturable microorganisms. We cannot quantify, but we can obtain the relative prevalence of each microorganism regarding to the total. Of course, this kind of analysis requires a laboratory microbiology lab, and also a specific equipment to do molecular biology. Also, we need specialized technicians, and it takes time because it is very demanding. So we need 1 week, and we detect all bacteria, viable and not viable, because we are focusing on the DNA. And the other option in DNA sequencing is to identify, to do the whole genome sequencing, to identify specific strains. As you know, the European Commission has published an implementing regulation that will be effective in August next year. And from this date, all foodborne pathogens that can be related with foodborne outbreaks, for example, Listeria, will be sequenced. So if we detected one of these microorganisms, like Listeria monocytogenes, in our food industry, and it can be related with a food outbreak, the authorities will be compulsory to be sequenced. So in this case, the first step is different, because in this case, we have identified Listeria monocytogenes, or another foodborne pathogen, in our food industry. So we have identified it, and we have a pure culture of this microorganism in a plate. So from this isolate, we take sample, and then we do the DNA extraction, we make the libraries, and we sequence the whole genome. In this case, we are interested in the whole genome because we are going to identify which strain we are talking about. In this case, it's not enough to identify Listeria mono. We need to identify which strain of Listeria mono we have in our industry. So, and after that, we need to do a bioinformatic analysis and the data. Obviously, it requires a microbiology lab and specialized technicians. It takes time, 1 week, and we are able to detect specific strains of Listeria monocytogenes with this type of analysis. And finally, to summarize, I would like to compare all the methodologies that we have explained, because all of them has pros and cons, and we need to know which one choose depending on our necessities and depending on our capacities. So, for example, if we focus on the time and the presence or not of pre-enrichment, traditional microbiology and selective culture swap and also PCR, we need 24 hours. In PCR, if we have a positive, we need to confirm. So in this case, we need 24 hours more. In case of traditional microbiology, we don't have pre-enrichment, but for selective culture swaps and for PCR, we have pre-enrichment. In contrast, DNA sequencing spends 1 week and not have a pre-enrichment. When it comes to the requirements, we need laboratory microbiology for traditional microbiology, for PCR and for DNA sequencing, and also specialized technicians. And for selective culture swaps, we don't need anything, only a mini incubator. So we can do it in any place, and someone can do it. Regarding to the cost, traditional microbiology and selective culture swaps are very cheap, and also the PCR, but in this case, we need to invest in the device. It's not only the kit, we need to invest with the device. And the DNA sequencing is the more expensive one, and also we need to invest in the device. Regarding to the capacity, for the traditional microbiology, the capacity depends on the capacity of the microbiology lab. And for selective culture swaps, we can do it 1 sample at the same time. And PCR and DNA sequencing have a high flow. For PCR, we can analyze 96 samples at the same time. And for DNA sequencing, we can analyze 24 samples in the same flow cell. And regarding to the detection limits, traditional microbiology has a detection limit of 10 cells. The selective culture swaps, it is between 10 to 2 to 10 to 3 cells. And PCR and DNA sequencing have a limit of detection of 1 cell. So depending of our necessities, for example, if we don't have a microbiological library and we don't need a very low detection limit, we can use selective culture swaps in situ and without laboratory and without technicians. But it is a general screening. So if we need to know if we have Listeria monocytogenes with a low limit of detection, maybe we can do it a traditional microbiology or a test with PCR in the laboratory. And if we need to know if we have a specific strain or which strains we have in each point of our production procedure, or we need to know the complete microbial ecology of our food plant, in this case, we will choose the DNA sequencing. So depending on our goal, depending of our capacities, and depending of our necessities, we will choose one or another method. That's all for my side. Thank you very much for your attention.
Brilliant. Thank you very much, Maria. So we are now moving on from arguably a very high-tech solution for microbiological determination to something more keeping with my experience highlights. And the next voice you will hear, young Mr. McCree from FreshCheck, who will be talking about a rapid bacterial determination methodology.
Peter,
Barry,
I'm going to say,
the floor is yours.
I'm going to say thank you very much for calling me young, but those who know me know that I've got about 40 years in food and drink, mostly technical sales, food projects, etc. But that's enough about me. I'm here to talk about a problem in food micro in that contamination is invisible when you're looking for microbes. By the time you smell it, it's a wee bit too late, and our job is to try and minimize the risk of microbial contamination throughout the food supply chain. We do rely on sight and smell and touch. We can feel some biofilms by being a wee bit slimy, but don't count on that because you won't feel them all. We can smell microbes, but don't count on that because by the time you smell it, it's too late. The responsibility of any company is to keep the food safe. Next slide, please, Peter. So hygiene verification. It's easy to get wrong, but it's relatively easy to get right as well, which is the good news. Do speak to experts. Expert advice is often free, and certainly I've received that from Chris Staines over the past, etc. And there's expert advice available from Fresh Check. Please come and speak to us. We're based in central London and further afield. In terms of hygiene verification, it often needs expert staff to set your systems up, but I'm here to talk about something really simple and easy to use. We supply and make swabs available to food and drink companies. That's all we do. Our swabs test for microbes. They're very cheap and easy to use. Next slide, please, Peter. Trying to keep to time. We've got a real-time solution. There's the swab. It sits in the palm of your hand. We make microbial and chemical contamination visible within a few seconds. One problem I've seen out on the factory floor is sometimes swabs are taken and incorrectly. So there's often training needed, whether it's for tech managers or QA staff. Where to swab and how to swab is where we need to start at a fundamental level. Our particular swabs change color within a few seconds, testing for live microbes, not dead ones, and testing for residual cleaning chemicals using the same swab. Next slide, please, Peter. So there we are. We've got some patented technology where we connect a dye to an ion. We use the presence of live microbes to break open that connection. It releases the dye within a few seconds, and we can see it in the bottom of our plastic tubes. Again, nice and easy, nice and quick. It's a quick visual check for hygiene cleanliness. Anybody can use it with minimal levels of training. Next slide, please, Peter. We've got a video that hopefully will start. There's the swab being used on a surface. We pop it in our patented dye. We give it a flick. There's an instant change. This is done in real time. And that tells me within a few seconds that there's live bacteria on that surface that's just been swabbed. And it's as quick and easy as that. The plastic packaging can be recycled, assuming we haven't got a positive reaction like we have there for live microbes. So next slide, please, Peter. There's a range of colors that we get from using our swabs. So within a few seconds, if there's residual cleaning chemicals that can cause taint on your foodstuffs, we get that lovely blue color on the left-hand side. If we don't pick up excess cleaning chemicals, we get a range of colors from clean, hygienic and clean, to a warning, clean it better next time, to a fail. There's a fair number of microbes there. Please re-clean your surfaces, re-clean your food equipment that you've just swabbed a few seconds ago. And if you get that color on the right-hand side, then it's a really big fail. Do your cleaning better, change your cleaning protocols, even look at changing your cleaning chemicals used on within factories. And I've been in many factories where the wrong type of cleaning chemical is used. Please call in the experts. Don't listen to a salesperson trying to sell you something that may or may not be right for you. Next slide, please, Peter. There's our swabs in terms of just looking at excess cleaning chemicals. So on the left-hand side, it's microbially clean. Within a few seconds, that we get that coloration in our swabs. On the right-hand side, we've got excess cleaning chemicals. So in the right lighting, it's easy to see. If we pick up excess cleaning chemicals, It will detect on the same swab live microbes if there is any, but it tends to take around about 60 to 90 seconds to get that result. So I often say, if you pick up that lovely blue colour on the right-hand side, pop the swab in your pocket, rinse your process equipment, have a look at the swab in your pocket a few minutes later, and if it's turned green, you know you've got some live microbes on there, so you need to go back and re-clean it properly with detergent, not just rinsing with water. If we know that there's residual cleaning chemicals on equipment, if the same kind of test was done with ATP, adenosine triphosphate, rapid testing, the RLU, the relative light unit numbers, will be false. So with the coloration that we've got, we remove that kind of chance of false readings in your hygiene verification system. Next slide, please, Peter. As with all things modern, we do have a digital dashboard. We've got a free app available that you can download onto various phone devices. You can download it into your PC. The dashboard allows you to sit on your deck chair worldwide and check what the hygiene results are within your factory several thousand miles away, if that's what you want to do on holiday. We can drill down into individual users of the swabs, so we can compare one QC person with another QC person. Do they give variable results in terms of using the swabs within the same factory? If that's the case, it's an opportunity to retrain them. We can drill down into individual test points, and we can trend data really easily at the touch of a button. If you get an auditor on site, be it a customer or an auditor from another body, within a few seconds of opening the dashboard, you can quantify and trend what's been happening hygiene-wise within your food and drink factory. So it's a nice, simple software system to have a look at. As I say, it's a free app to download. Please contact FreshCheck if you want some more information, or speak to Peter, who will hopefully get in contact with our good selves. We haven't got time to go into the data and the app today, but it's very easy to use. Even I can use it, so it must be easy to use. This little chart here, it compares our FreshCheck swabs with ATP swabs, protein testing. All three of them are lovely, quick testing methodologies. In terms of microbial sensitivity, ours only tests for live microbes. We don't test for dead ones. ATP, test for live, test for dead, test for organic debris. So if your interest is to minimize Listeria, if your interest is to minimize microbes in general, then we will give you a yes/no result quite quickly, within seconds, not minutes. Protein testing, if you get a positive test for protein, it may or may not be contaminated with live microbes. So if that's your bag, then that's fine. Micro testing tends to take time. Very, very microbially accurate, but it does take time, anything from 24 hours to 2 weeks to get your results back in terms of Listeria mono on site, for example. We do have smart device accessibility with FreshCheck. ATP systems often are not used and accessible worldwide. I'd like to think FreshCheck swabs are easy to use compared to others. Storage, our swabs can be stored in ambient conditions. We don't need a fridge. If you want to go and audit your suppliers, pop the swabs in your top pocket, put a box of swabs in the back of your car, away you go. And the swabs are good to use when you get there, whether it's within a few hours or a couple of weeks to travel. ATP swabs, if they're out of a fridge, can be quite quickly out of specification. Micro testing, likewise. If you're reliant on lab testing, please be aware that there's time taken from taking the swab to getting your results back. Next slide, please, Peter.
Apologies, Barry, I was a bit quick on the finger there.
That's all right. You're allowed. In terms of market trials, we agree with about 95% of ATP test results. That little difference is that we focus on testing for live microbes as opposed to dead ones and general debris. So if your focus is to minimize the presence of live microbes, please speak to us directly or contact Chris Staines, who will contact us to share your details and move forward. Next slide, please, Peter. Within the app, we've got these photographs. We can take photographs of what's been happening within your factory. These photos have been taken direct from the app as a factory case study. We're quite happy to send out a redacted UK food and drink factory case study where we trialed about 16,000 swabs. This particular factory went on to use FreshCheck swabs. They ended up saving £43,000 a year by transferring to us. By reducing the ATP swabs they used, reducing the lab test swabs that they used. So they saved cash, they tested more test points, and more importantly, reduced their manufacturing risks by using something really simple. And personally, I like simple things because simple things work. And Peter asked me to be brief and to the point. I hope I have been. If there's any questions, you know where to find me in the usual places. So I look forward to meeting you all soon. And Peter, I'm done.
Fantastic. Thank you, Barry. So I've seen quite a bit of traffic in the chat whilst Maria and then Barry has been talking. So we'll spend the next sort of 15, 20 minutes just pulling together a lot of those techniques and also introducing you to another technique that I've been getting very excited about, much to the delight of many of my friends and colleagues. Maybe slightly too excited, but hey, you'll see why in a few moments. So we want to talk about rapid methods of detection and more importantly, control. So just to summarize briefly something Maria was talking about earlier, traditional microbiology, it takes days, it requires a lab. Even with the rapid swabs that Maria was talking about there, as you'd have seen on the table as it went through, we're still talking 24 to 48 hours, excuse me, with pre-enrichment to get a result. And we need to incubate. For me, the other big problem within factories is unless you've got laboratory facilities and containment facilities, you're potentially growing the very pathogen that you don't want in your factory, which can cause a bit of a problem. So that's traditional microbiology. Where a couple of years ago, we came across a small French startup who produced a very novel little technology called Lupix. They initially produced it for SARS-CoV-2 assessment and then developed it further for food assessment. And this is giving us some real benefits and is starting to prove very, very popular. There's no pre-enrichment or incubation stage. The first stage, as you'll see shortly, of the technology is to destroy any bacteria cells, and it's exclusively available to Chris Daines for us to make available to our customers and to anybody who is interested in actually getting control over Listeria rather than simply managing it. And the system works very, very simply. We take a sample, swab, very similar to Barry as he was talking earlier. We carry out lysis in the device at 95 degrees Celsius. The unit doesn't get to 95. It's only the small heating block inside that does. So it's still cool to the touch, so it's quite safe. This releases the genetic material into solution, which we then purify. We then put that purified sample through a LAMP PCR genetic multiple identification, and that gives us a readout of presence or absence. So from starting that process of lysis, you can have a screen reaction or screening of your surface swab within 90 minutes. So yesterday I was doing this at a site. We took some swabs, went back into the office, sat down, and within 90 minutes we're staring at, as it turned out, green not detected lights, which was superb. So we can actually screen for Listeria at the species level and then carry out a further 20-minute test to determine whether we've got L mono present. We'll see that in a few moments. So just to show you, to reinforce, first we sample with the swab. We'll then introduce it to the Lupix device, which is 7 by 7 centimeters. So we're not talking car battery size here. We are talking sort of not much bigger than your mobile phone. smaller than your mobile phone if you're on an iPhone Max. We then purify. We then carry out analysis, again, back in the Lupix same device. Press the little button, off it goes. That can take less than 60 minutes, depending on the species we're looking for. And it is a pathogen detection solution for a food processing environment. No live bacteria at any point, and we can go from that swab to the result in less than 90 minutes. And the result looks just like that. So on the left-hand side of the screen there is a Lupix box with the not detected, the green light. The right-hand box is a red light, which is detected. Simple as that. It allows us to do faster pathogen screening. So it's less recalls, less waste, follow-up on hotspots, intermediate cleaning validation. It gives us in-house monitoring, so we don't have to send anything out. We can actually cut that transit time, and you'll see in a case study we'll look at in a few moments how that can be of benefit. And it enables immediate response to potential contamination incidents. I've been at sites where they've carried out a clean, know they have the odd hotspot, particularly for mono, and within an hour and a half, 2 hours, I've been able to then say, right, you've not only got Listeria species on that conveyor, but it's also mono, and that's now. So straight away, hygiene manager picks up his phone, phones production director, don't start the line. Simple as that. So we were able to block the contamination from actually reaching product. We'd taken parallel traditional swabs at the same time, and the following week we got a phone call to say, you know, those Lupix swabs we had were positive. Yep, traditional micro said the same. So for the last, those of you can see on our screen can see the bit like Barry, the experience highlights, as I like to call them, from the 30 odd years in the food industry. I've spent hours climbing around in high care factories and high risk factories, carrying out Listeria investigations. And it's always been take the swabs, wait a week, right, how did we do? This is the first and only technology I've found that lets me control Listeria. I can take a swab, I can run an analysis, and I can stop it in its tracks. I can say it's there now, not it was there last week, but it's there, it's on the surface, we need to do something about it straight away. If you're looking at practically implementing that rapid testing and that control, this is where we have a collaboration between ourselves and FreshCheck, because we know we have a viable population of bacteria on the hotspot from FreshCheck. One of the challenges, and I noticed my old friend Greg Jones is on the call, and one of the things he always used to love when I stuck my hand up to talk about a DNA analysis was, can we tell if it's live or dead? That's always been a problem with genetic systems. By tying up FreshCheck, which gives us an indicator of viable bacterial populations, with the Lupix technology, we can tell if we've got viable bacteria and whether we've got Listeria at the species level, at the monocytogenes level, or Salmonella species or E. coli species. So we're developing more and more target pathogens for this system, all from the same box. If we look at that in a flow chart, you can see running from the very top of the screen there. We start with identify our known hotspots. We'll swab that sample area using a FreshCheck swab. If we don't get a positive reaction on the FreshCheck swab, there's no point doing anything further, because we know we haven't got viable bacteria present. So we can use a very quick, very simple, very inexpensive test to help us direct our more expensive and detailed analysis. Now, if we have got live bacteria, we test with Lupix for the species level. As we said earlier, takes about 90 minutes. We're sitting there looking at the machines flashing, and we get either a red or a green result. If we get a green result, we're fine, we've got bacteria, but we haven't got Listeria. If we get a red result, we know we've got Listeria at the species level there. We can then take that retained sample, introduce it to the second reaction tube, and within about 15 to 20 minutes, determine whether or not we've got Listeria mono present. If we have, we then carry out a decontamination regime. To be fair, if we've got Listeria at the species level, we're going to carry out a decontamination regime. We then can swab again with a second fresh check swab to confirm removal of the viable living bacteria. So we bookend our genetic testing using the Lupix device with a fresh check swab. So we go fresh check, have we got bacteria? Yes. Have we got Listeria species? Yes. Have we got mono? Yes. We're now starting to panic a bit. Have we removed all viable bacteria from the surface? Also, yes. So for the first time, we've actually got a control mechanism for Listeria. We can get in front of it. We can stop it causing a problem in the first instance. And we've done this in a sandwich manufacturer. In fact, we've done this in several places, but I've just pulled this particular case study out. So within the UK, as Karen was talking about earlier, our sandwiches traditionally have a 3 to 4 day shelf life. So if you think about the early technologies that Maria was talking about, where you're talking 4 or 5 days for a result, your result is coming in about the same time your product has left its shelf life. That's assuming it's tested on day one. However, we have very decentralized micro testing facilities here in the UK. Very few sites I go to have their own pathogen lab on site because they don't want to grow the pathogens and have it escaping. So they use wonderful companies like ALS to actually carry out that analysis for them. So the sample is taken on day one, day of production. Great. Collected the following day in refrigerated vehicles. If it gets to the lab in time, that test may commence on day 2 or it may commence on day 3. We then get presumptive Listeria on day 5 and confirmation on day 6 or 7. So by the time we get the results back, the product has not only gone out of its shelf life, it's passed through whatever human consumed it and is out the other side. So it's gone. We have no chance of getting it back. Using FreshCheck and Lupix in tandem, we can test and control on day 1. So you can see on the devices there, we confirmed with the FreshCheck we had hotspots. We carried out Lupix analysis on 5 samples using 5 devices, and we had 1 positive detection shown from the red arrow there. We then did an additional 20-minute test and confirmed that it wasn't L mono. We didn't know which it was, but we know it's not mono. And a week later, the parallel swabs confirmed that the NOT detects were either Seligeri or Inocua. So we know we have something there, but it's not that. The second visit, we took 6 swabs. We were getting emboldened. And as you can see on there, we had 5 negative Lupixes. We then took the detected Lupix and confirmed that it was mono. And again, the parallel swabs confirm that 20 minutes later. So from saying we can do a test and say we have got Listeria species, we haven't got mono. In this particular instance, we not only had Listeria at the species level, but it was a monocytogenes detection. So that instigated a different reaction. A very quick reaction, I have to say. And as I say, that was all confirmed with traditional micro. So we can utilize these technologies to really support the total Listeria management elements that we were talking about earlier, where we have the inspection and review, as we've talked earlier today, Richard spoke about, the chemistry for removal that I covered, training and awareness that Richard covered to ensure that staff actually know what they're doing and what the consequences of failure are, and then rapid and effective screening for Listeria species and mono on site. So we really do have now a technology available to us that enables us to control that bacterium rather than simply reacting or managing its presence a week later. We're going to head into the Q&A in a few moments. We're actually running amazingly to time, which anybody who's been on a webinar or a presentation I've done before will know how amazing that is. So we'll have quite a few minutes. For those of you that aren't familiar with Chris Staines, hopefully you all are, and you're here. If you're not, we do have capabilities to look after you worldwide. And we have both our own production units and we have distributors in many countries as well. And we are owned by the gentleman grinning in the bottom of the corner there. That's Alan Bostoon. He is our owner. So we have a very lean structure. We have family values. We take our responsibilities as your hygiene partner very, very seriously. We know that you're relying on us to help you manage your food safety requirements, and we are looking to continuously improve your operations. Hence, looking at things like Fresh Check, looking at things like Lupix. Obviously, we do everything that you'd expect from a major international multinational chemical company. So we do the products, we do the education and training, as Richard was talking about earlier, and we have a very thriving training academy, particularly in the UK, where we have accredited courses that we can deliver via Teams. We have that service to support and assist you, as Barry was talking about, and the actual on factory floor. Most of our people are recruited from the food industry. So they've been there. They've been there at 3 o'clock in the morning when the water's run out, or when it's gone cold, or when people haven't turned up, or when production has overrun. We've got hygiene monitoring systems, very similar to the things we've been talking about earlier. And we obviously have equipment to enable you to carry out the clean. So we will now stop sharing the presentation so that you can gaze upon our collective loveliness. And we'll look to the questions in the Q&A session. So if I stop sharing and open up the chat, I think we've been answering quite a few questions as we've gone through today. Got a question on the management PowerPoint. We will be sharing, as I said, the recording of this seminar, this webinar, at the end. If Microsoft Teams does its thing correctly, then you should automatically receive a link in half an hour or an hour or so. If it doesn't, we'll send it out manually. I have colleagues here at Warrington who are signed on, so will be able to tell me whether they get that link. Sometimes Teams does it, sometimes Teams doesn't. It's one of the joys of working with technology. Messages pinging through. Barry, one for you. There is a question of, will fresh check swabs show as excessive chemical present when taken after final disinfection where it's not been rinsed off?
To answer, yes, but it depends on how much residual terminal disinfectant or cleaning chemical is left on the surface. The easiest way is to try the swabs and give it a go. Our swabs are designed to be used after cleaning and ideally before you put your terminal disinfectant on.
Okay, we have a question. Karen, this one's a perennial. Would it be better to swap our sanitizers every now and then to avoid it building an immunity to a specific sanitizer?
I'll probably refer you to a GFSI paper on the biocides, on the use of biocides. I'll put a link in the chat, but it's debatable whether this is necessary. If you actually kill the organisms by using the correct concentration, don't leave it hanging around because it will lose efficacy. Appropriate contact time, and of course the right means of application. I mean, if the organisms are actually killed, then they're not going to come back and haunt you. You just have to keep the place clean and keep the biocide treatment going. So I would debate that. I'll find that link for the GFSI paper which made those points. Anybody disagree?
Karen, if I could just break in there, my best practice is, whether it's 1 day a week or 1 week per month, change your terminal disinfectant from an amphoteric to a quat or a quat to an amine. And it's cheap as chips, and it just takes a tiny amount of management to do. So please do that, and you kill more bugs.
I would actually disagree with you on that one, my friend. There is a big move away from, as you know, from quats with the regulated RLs, which we won't start me and Karen on, because we will keep people here all day, or at least those that cling to the wreckage. In terms of practical factory applications, I've never seen a resilience being built up to the formulated products. certainly the active biocides, then yes, there is some evidence that sublethal concentrations, as Karen was saying there, can lead to survival and persistence rather than resistance. But I've certainly not seen anything becoming resistant. This tends to come from a misconception of the way that biocides work, where we have resistance to antibiotics. If we can inject ourselves with disinfectant, then we would certainly have less residual antimicrobial resistant organisms. And I'm not suggesting, as we saw on the TV a few years ago, where a certain world leader was advocating taking bleach to deal with his COVID problems. So we're not going to go there. Maria, as a microbiologist of great repute, would you have any thoughts or comments on that one?
I completely agree with you, Peter, because it's not the same an antibiotic or a biocide.
Can you just say that again? I hear it so rarely that nobody actually agrees with me.
Because it's a reality that the resistance to antibiotics, it's a problem nowadays around the world, but for biocide it's not the same. There are bibliography, published articles talking about that, but the resistance that they have found it nowadays are to a very low concentration of biocides. And the concentrations that we use in the industry are much more higher. So it's not a problem nowadays. Fortunately.
I just put something in that the research papers always use minimum inhibitory concentration, which isn't biocidal, because otherwise you wouldn't get anything growing and couldn't draw any conclusions about. It's not resistance, it's tolerance, because it's just phenotype, there's genes or whatever, the genes are there. But so, and I remember the last time I challenged this was somebody, I think it was a PhD candidate at Quadrum. Perhaps I said too much there actually. And I said, why are you using MIC? And he said, because my professor said so. So using sublethal accounts of something that's supposed to kill is obviously not going to kill. It's a one woman challenge on that one. I think I have some friends here though.
You do it. I can certainly agree that we see sublethal concentrations, unfortunately, too frequently, either due to time or often wet surface. I mean, bear in mind, if you're applying a disinfectant at 1% vol as a solution, and there's water on the surface, you're 99% water. If you've got a wet surface and a slightly concave surface from the fact that people have been sat on it before, you're going to end up with a sublethal concentration of biocides and of active formulations. Let's just have a look. We've got some other questions coming through. We've got questions about costs. I'm not sure whether that was to do with costs with FreshCheck or with Lupix, but we'll come back to you on that one. It's a question from Nigel. The Lupix, we actually lease the device because it's essential that it's calibrated on an annual basis, and it can work out as low as 30 to 40 euros per month to actually lease one of these devices. One device, one sample at one time, so it is a batch process. The actual cost per test varies around between 15 to 22 pounds sterling, so about 18 to 25 euros. Maria, is that about right? I think it's not far off difference at the moment.
Yes, more or less.
More or less. Depends on the exchange rate.
Between 20 and 25.
Yeah. Question that comes up quite often about limits of detection. With genetic systems, we're not looking at CFUs in terms of LODs. We're looking at relative limits of detection. And that could be very simply because if we've got happy bacteria growing away quite nicely in their log phase, expressing lots of genes, we could pick up really low levels of bugs, as Maria showed with her PCR of one cell. However, if we've got beaten up stressed bacteria that have been through hell and back, they're in their lag phase and their level of expression will be dramatically reduced. So unfortunately, Greg, the question on LOD is, it depends on how happy your bugs are. And if you think about a lot of the third-party recommendations for Listeria analysis, the majority of the swabs are advised to be taken during production or pre-clean rather than post-clean. If you've got a good validated hygiene regime for cleaning and disinfection, then you should have little to no bacteria left. So some of the third-party standards, one I'm thinking of in particular from a very large retailer, talks about 80% of your swabs being during production or pre-hygiene and only 20% being post-hygiene, just to confirm that you've not got anything left hanging about. I think that, so yeah, we are working with the RLOD at the moment as we are with external certification. One of the problems we have with external certification is there isn't a certification scheme that we've come across that is written specifically for non-pre-enriched genetic-based systems. The current ones like AOAC are written for a pre-enriched system. I think I'm correct in that, aren't I, Maria?
Yes.
Perfect, thank you. Oh, I like inviting Maria to these things. She's great. Clear and succinct and to the point. Let's have a look. Just scrolling through.
Peter, before you move to the
questions.
next question, we do have a report from Camden BRI regarding using fresh check swabs. So if anybody wants to look at that, various microbes at various levels of detection, it's
Yes.
free to send out. So whether you get it direct from me or from you, Peter, I'm happy.
That's fine. Yep, I think we've got that on a, yeah, Richard certainly I know sends that out quite a bit. So that's linked to the case study I think you presented on, wasn't it, Barry?
It was a straightforward report by Camden that we asked them to do on our behalf. So Camden's, you know, a relatively good lab to use and pay for their services. Wasn't cheap, but there you go. It says what it does on the tin.
Thank you. Brilliant. Thanks, Barry. Karen, question here. In your presentation, you stated that Listeria doesn't survive past minus 18 degrees. Is this only if there isn't a biofilm?
No, it survives minus 18. It does survive. That's the whole point. So it survives freezing. It just goes into suspended animation. I'm not sure if you could resurrect it from a nitrogen minus whatever 270 Celsius, but certainly it survives freezing. It survived almost anything except a decent 6 log reduction process, 70 for 2 or above.
Okay. I have a question.
Yes, we have detected. Sorry, we have detected Listeria mono inside of a biofilm inside of a tunnel at minus 80 degrees. So the biofilm protects them and it's able to survive.
Yeah, I mean, it's to be expected. It's yeah.
Which is yes, as you say, biofilms are. When I started in the industry, me and Barry many years ago, and we were still wearing short trousers, biofilms were talked about in very quiet, hushed tones because we didn't know how to find them, and if we did find them, we didn't know what the heck to do with them and how to remove them. We have a lot more knowledge and expertise in that area now, and bizarrely enough, during the break, Richard and I were talking about we'll pull together a webinar specifically on biofilm and biofilm control in the very near future. So keep an eye open for that. That links to a question we've been asked of how many types of biofilm does the TBF 300 work on, which was the pink spray that I showed on the slides. I think I'm right in saying, Maria, all of them.
Sorry, can you repeat?
Yeah, asked a question about the types of biofilm. How many types of biofilm does the TBF 300 work on?
All of them.
All of them, yeah.
We are detecting the matrix of the biofilm.
Perfect. So it's not species it's not the species within the biofilm that determines whether it's detected. It's the EPS layer.
No.
Perfect. Thank you very much. Right. We are rapidly approaching the end of our time together. I can't see any questions that we've missed, although finding the questions is quite difficult amongst all the superb links that Karen's been posting. Thank you, Karen.
Sorry about that.
No, that is fantastic. That is absolutely brilliant. And looking at the feedback coming in on the chat and on the Q&A, I think it's fair to say that everybody has found today of real benefit and really interesting. I certainly have. I've certainly learnt new things as well. So I will put out a final call. Oh, a couple of questions slipped in. Hang on a second. There's a question here from young Mr. Graham. Good afternoon, John. Is Lupix only specific for the... Sorry. My pop-up keeps coming across the top of question. I'm trying to read the implement thing. Is Lupix only specific for the identification of Listeria or other bacteria or pathogens? We can currently do Listeria at the species level, Listeria mono, Salmonella at the species level, E. coli at the species level, and we are starting a project looking for Campylobacter. So we've got the little box technology. We just now need to find the actual target organisms that we wish to hit. And Maria and I did sit down a few months ago with a couple of our colleagues, and we produced a very long list indeed of things we'd like the devices to find, which can all be done. It just takes time to find the sequence and validate it and make sure that we've got it correct. There's a question here as well about risk assessment of Listeria mono and testing methods. Real food safety risk laid down at the quantitative analysis of List mono. Why majority of UK retailers, coming your way, Karen, reject criteria already while Ivanovi or Inocua are considered as hygiene indicator? So what I think the question is asking there is, should we be reacting more to other species of Listerias as well as mono?
Okay, well, there's no real legal basis for that. And I was thinking of this earlier today because I've got something coming up next week where this features. So 28 species of Listeria, and only there's 8 genetically closely linked to monocytogenes, and the other how many is that? 19 are more distant from monocytogenes than we are from chimpanzees. Right. So there was just go back to Martin Wiedmann in I think it's at Cornell, anyway, in the USA, and he did a paper at IAFP I think a couple of years ago, the European one, which goes through this, and he's arguing that most of the Listeria species shouldn't actually be called Listeria, that genetically distant. But Ivanovi is more closely linked with mono, but you might get somebody enforcing this might get themselves in the mess. Remember, was it Lanarkshire blue cheese? Ooh, and there was a bit of a fuss where the company, they found species, and of course it wasn't as sophisticated as now, but they didn't find mono. Then there's enforcement action, went to court, the company, it was terrible for the company, and the judge agreed that it's not monocytogenes on your bike enforcers. And that was, I think, the Department of Health was leading on that one. Anyway, so there's different legislation now, because that's pre the General Food Law 178/2002, which has its clause 14.8. But it's an indicator just of environmental presence of LM. But LM is present. I'm looking at fields now. It's swimming with Listeria species, but not necessarily of mono. So yeah, just be careful. But it is because we don't find Listeria mono frequently enough to because we're controlling it in these factories. We've got less than 1% positives, less than 0.3% positives on surfaces during production, or food contact surfaces during production or post hygiene. And so you need to do a hell of a lot of swabs to find a mono. So this is why species generally are used as a hygiene indicator, but legal basis now. And only monocytogenes is recognised in law as being a human pathogen. I'm aware of one paper somewhere where I think it was a German buffet, a woman became ill, and it was Ivanovi or something like, there's something very vague in the back of my mind, but There's no real evidence for any other pathogenicity in humans from other species apart from mono. That was a short answer, wasn't it? Not.
That was precisely the sort of answer I'd expect from you, Karen. Detailed, informative, and brilliant. Thank you. No, that was superb. Right, folks. Well, it's just coming up on 30 minutes past the hour, so we will pull things to a close there, and I will give you back 3 minutes of your life you weren't necessarily expecting to have. So thank you to the people that have stuck with us through the Q&A session. As I say, you should be receiving a link to the recording at the tail end of this session. Not, we will make sure that we will get it to you along with a white paper on total Listeria management, which contains a lot more information than we were able to cover today. And looking at some of the messages I'm receiving through chat, keep your eyes open for a biofilm webinar very, very soon, because there's a lot of messages coming in saying we'd love to see that. So thank you all very much. Have the great rest of your day wherever you are in the world, and if you need us, please contact us at www.sustains.com.
Thanks for the invite, Peter. Cheers.
Bye all.